Today, we're going to crack the code on one of nature's oldest secrets. We're talking about a plant's recipe for making its own food. I mean, this is the process that powers pretty much all life on Earth, and we're about to see exactly how it works, step by step. Seriously, just think about that for a second. What if, instead of making breakfast, you could just step outside and soak up some sun for energy? Now, obviously we can't do that. But you know what? Plants have figured out how to do something incredibly close to it. They've cracked the code on turning sunlight, air, and water into actual food. You probably learned the basics in school, right? A plant needs water, air, specifically the carbon dioxide in the air, and of course, sunlight. But look, knowing the ingredients is one thing. Understanding the recipe, the exact process that turns all that stuff into food, well, that's the real secret we're about to uncover. So to find this secret recipe, we need to know where all the cooking happens. Think of a plant's leaf as a giant factory. Inside that factory, you've got millions of tiny little workstations. Those are the plant cells. But if we zoom in even further, inside each cell are these microscopic green machines called chloroplasts. This is ground zero. This is where the magic really happens. Okay, so here's the problem. Chloroplasts are way too small for us to see them in action. So to get a peek inside this tiny molecular kitchen, we're going to use a really cool tool, a computer simulation. This is going to be our virtual lab, and it's going to let us watch this whole incredible process unfold right before our eyes. And here it is. This is our window into the plant cell. See those big green circles floating around? Those are our chloroplasts, our little green machines. And all those tiny little things bouncing all over the place, those are the molecules, the actual ingredients we're going to be tracking. Think of this as our little cheat sheet for the lab. It's really simple. The inputs we're starting with are water, that's the white and red molecule, and carbon dioxide, which is the black and red one. And we'll be looking to see if the simulation creates our outputs. Oxygen, which is two red atoms stuck together, and the grand prize, sugar, this bigger, more complex molecule right here. All right, first things first, we're just going to press play. Let's run the simulation with all the normal stuff a plant would have. Plenty of water, carbon dioxide, and light. We need to see what a healthy functioning plant cell actually does. This will be our baseline. Whoa, and there are the results. Just look at that transformation. We started with simple water and carbon dioxide molecules, but by the end, we've got two totally new things, oxygen and sugar. This isn't just mixing, you know? The original ingredients have been chemically rebuilt to create something brand new. Now, this amazing process we just watched has a name, and I bet you've heard it before. Photosynthesis. That's the official term for how plants use light, the photo part, to synthesize or make their own food from these really basic ingredients. It is quite literally the foundation of their survival. Okay, so we've seen what's supposed to happen, but how do we know every single one of those ingredients is absolutely essential? Well, any good scientist is going to test their assumptions. So that's what we're going to do now. We're going to start taking ingredients away one by one and see what breaks. Let's start with the most obvious one, right? We all know plants need sunlight. But just how critical is it? What happens inside that tiny chloroplast if we just flick a switch and turn off the lights? Wow, the results are crystal clear. The second we set the light level in our simulation to 0, the output of both sugar and oxygen just flatlines. 0. Nothing happens. So here's the takeaway. Without light, the entire factory just shuts down. It's not just another ingredient, it's the power source. Okay, so light is a total non-negotiable. Got it. But what about the air? I mean, plants are surrounded by it all the time. Is that carbon dioxide part of the air really a key building block for making food? Let's find out. And, yup, once again, the result is completely definitive. When we take away all the carbon dioxide from the simulation, the production of sugar and oxygen grinds to a dead stop. 0. So get this, a plant can have all the sunlight and all the water in the world, but without CO2, it simply cannot make its own food. Period. Okay, so we've run our experiments, we've gathered our evidence, we've proven that light, water, and carbon dioxide are all absolutely essential. So now, after all that, we can finally write out the official, proven recipe for photosynthesis. So here it is, the secret recipe. Step 1, the plant gathers its raw materials, water and carbon dioxide. Step 2, light zaps the chloroplasts, acting as the catalyst that kicks the whole thing off. Step 3, and this is the amazing part, the atoms that make up the water and CO2 are literally ripped apart. And then step 4, those loose atoms are put back together in a new way, forming brand new molecules, sugar for food and oxygen as a waste product. You know, this quote just nails it. Photosynthesis isn't like mixing a cake batter. It's more like being a molecular construction worker. Plants are incredible architects. They break down these simple materials and build complex food right out of the atomic rubble. It's incredible. So we've cracked the recipe, we know the ingredients, we know the steps, but our little investigation here, it's actually uncovered one final and much deeper question, a bit of a mystery. Just think about that for a minute. We've proven that all the building blocks, all the actual atoms that make the sugar, they come from the water and the carbon dioxide. Sunlight isn't made of atoms. So if it's not providing the matter for the food, what is its role? What is the light actually giving to the plant? Now that's a question to chew on.